Hello and welcome to Jamper Antennas and Alan Dick broadcast presentation. In this presentation, we're going to look at antenna solutions for digital television. So when we're looking at antennas for digitals, particularly when adding either new digital channels to an existing antenna, which could be either analog or digital, we need to consider if we want to add to the existing system or put up a new system. And depending on what you'd like to do, that would also indicate what type of antenna system would be suitable. So if you're just adding a brand new antenna, single channel, then you only need limited bandwidth, and that may be like a simple and quick solution if you just need to get one channel on the air quickly. But if you have existing frequencies or you have the ability to get multiple customers, a broadband solution where you multiplex multiple channels may be a better solution. It may be a more complex solution initially, but it gives you a lot more flexibility. And the other antenna options that we have is for gap filling, which is where you have your main site, which is a sort of traditional analog model, but then you also want, with digital, you have the ability to do single frequency networks, and you may be able to fill in gaps. And so there's other products that are focused towards the gap filling part. So the main products we have, antenna products we have for digital broadcasting, are panel antennas, slot antennas, which also includes broadband slots, super turnstile antennas, dipole arrays, and we also have some indoor antennas which could be used for gap filling. So we'll talk about those products. So the first product, which is very commonly used for many years in the broadcast industry, is UHF panel antennas. They cover the whole UHF spectrum, 470 to 890. They're very modular design, so you can use one panel, you can use multiple panels, and depending on the panels and the physical location, you can produce customized patterns or omnidirectional patterns, directional patterns. And they're normally covered with a fiberglass radome protection. And we have lots of different types of UHF panels. We have horizontally polarized versions and vertically polarized versions. And we also have circularly polarized and even elliptically polarized, where the ratio between the horizontal and vertical is not one. It's slightly more horizontal or slightly more vertical. And we even have panels where you can adjust the polarization after installation, depending on how you feed the antenna. And so this is a typical example of a high power panel antenna. There's actually several shown here, but this main one in the full picture, this is actually in Jakarta in Indonesia. So this is a high power antenna. It's doing 320 kilowatts transmitter power at UHF with 5 different channels in total. And this is on a very tall structure, 400-meter structure. So this obviously covers a large area. And so it can be very high power. The panels can be very high power and a large gain and any pattern. So the type of patterns, the standard sort of patterns we get with the standard panel, if you have 4 around, you have like an omnidirectional pattern. If you have 3 panels around a square, you get like a wide cardioid. 2 panels will give you a narrow cardioid, or maybe a peanut if you point in opposite directions. And then a single lobe is just a single face of panels in one direction for a more directional pattern. So as well as the kind of 4 around type panel, we also have panels that would go 5 around a pentagon. This is an example of an antenna in the UK. And this, similar to the 4 around, but obviously just 5 panels around, it allows maybe a bit more space inside the antenna for access. And you can put even more power in because you have 1 more panel per bay or per tier. And then there's even wraparound solutions where there's multiple panels around. So it's this antenna lower down here. So this can be 18 panels around or even more than that. And this can give a very omnidirectional pattern. It also gets over the problem if the tower is too large, then you put lots of panels around, and you can still get a very controlled pattern. Ideally, you'd want a smaller spine like this, but if you have to go around the tower, this is a solution to get a very controlled pattern. And there's many of these installations, particularly in the UK. So the advantages of a panel antenna, they're very broadband. The power levels vary from low to high, so really as any range that you want. You have a lot of flexibility on the azimuth patterns. You can have standard customs, again, very flexible. And also our elevation patterns are very flexible because you control the power and the phase to each individual panel, and that really gives you a tremendous control on the pattern. You have a corporate or parallel feed system, which helps to have good impedance. And if you have many panels, that technically, if one panel failed, you'd probably remain on air, especially in a large system. It wouldn't affect the impedance too much, and you could carry on broadcasting, which is potentially an advantage. Some of the disadvantages is when you have a large antenna array, there's quite a large weight and wind loading to that, which means that your tower has to be stronger or strengthened. And because it is corporate feed, there are many cables and splitters and power dividers, and it has to be installed correctly. So it makes the installation more complex and just more components. And if you do mixed polarization or even polarization that you can change, it increases the complexity further. So there's a lot of components. You have to look at how it's going to be mounted because of the stress it will put on the tower, and you need quite a lot of planning. So kind of the opposite of the panel antenna is a slot antenna. Again, you can have a good range of power. It's maybe the absolute top power isn't the same as a panel, but it's still very high power, as you can see. You can also have different polarizations. You can have horizontal, circular, elliptical polarization. And again, there's different designs. You can have different beam tilt and null fill. They can be side or top mounted. And because there's a lot less components, the installation's easier as well. And as a company, we produce slots antennas for well over 30 years, so it's a very common product to us. And we have a range of models depending on power. So we have and size. So we have a kind of lower cost, smaller size one like the JESS, and then we go up in power and size to 120 kilowatts, very high power, and everything in between. So one of the things with slot antennas is originally they were designed, they would really only work on one UHF channel, so they would have 6 or 8 megahertz bandwidth only. But we, as a company, have been designing and supplying broadband slots for many years. And when we talk about broadband, we don't mean 2 channels, we mean 10 channels or 20 channels. So 50, 60 megahertz or even 120 megahertz. And we've even done broadband slots that have had 200 megahertz of usable bandwidth. And again, you can have multiple bays for different gains, and you can have standard patterns or slightly more complex patterns, and they can be side or top mounted as well. And this is a impedance plot of one of our broadband slots from actually many years ago, and this is showing over 100 megahertz of usable bandwidth at a very good VSWR. And so the advantages of a slot antenna, they're physically much smaller, so the weight and more importantly the wind loading is 50 to 75% less than a panel system. I say the wind loading is more important because towers are normally, compared to say a building, they're actually relatively light. They're just steel, there's no concrete there. So the weight on a tower is not that important. The towers don't tend to sink into the ground. When towers collapse, they normally fall over. And so it's the wind loading, it's the sideways push that is a more critical factor on the tower design and the weakness of the tower. So the wind load is really the key parameter that the slot antenna reduces, so that you can put it on a lighter tower, or you can put a bigger slot antenna. And as I said, we do broadband slots, a wide range that accept multiple channels, many different power levels, and again we have choice of patterns, not quite as wide as the panel antenna, but still a lot of different choices. And it's actually much easier to implement elliptical and circular polarization because we can do that with outside elements that just couple onto the vertical polarized the vertical polarized part. So in terms of cost and adding it, it's a lot easier than on a panel antenna. And mechanically, it's more simple, which and that also makes it a lot easier to install, less connection, less parts to go wrong. So the disadvantages, even with our very broadband slots, they're not absolutely full band, so they are bandwidth limited, but most of the time that's not an issue, because if we side mount them, then the tower can affect the antenna if it's mounted on the side, but if it's top mounted, it's not really affected. And because it has a certain bandwidth, if you want to add frequencies in the future that are outside of the band that it works, then that's unlikely to be possible. So just to further compare the panel and slot, particularly from a mechanical and point of view, this would kind of give you an indication as if you had a weight or wind load, as I said, particularly wind load limit, you could have a kind of smallish aperture panel antenna, which would have small gain, which means that the coverage would be small. But for the same weight and wind loading, because the slot antenna is physically smaller, you could have a much larger aperture. So it's a taller antenna, which means the gain is higher and you'll cover more. So for the same tower loading, you could have a lot larger coverage with a slot antenna. Or to look at it a different way, if you have the same gain, which generally means that the height of the antenna is the same, the aperture is the same, then with the slot antenna, you'd have much lower weight, much better weight, and also much lower tower stress, better tower stress compared to the panel. That would be worse. As I said, adding circular or elliptical polarization to a slot antenna, it's really still physically it's the same slot antenna, and we put coupling elements within the slot to do that. If you have if you want to do that to a panel antenna, you essentially need a more complex and different panel, and you will need 2 times the feed system to add that. So more points of failure. So whilst the panel can be very flexible, it also has some downsides as well compared to the slot, even when looking just at polarization. So as well as those products, we have a super turnstile, a JATU super turnstile. This is generally a top mount solution. It produces a very omnidirectional pattern and works in the way that super turnstiles work. We have a few different sizes for a range of gains from 5 to 11 dB and different powers up to sort of 10 kilowatts. And it's physically it's larger than the slot antenna, but it's smaller than the panel antenna. And it's a good kind of medium to low power solution for digital. Would be, for some of the smaller ones would be good for rooftop installations. And then we also have a dipole array or cardioid antenna. This is being used in many locations in the UK. This is vertically polarized, and it produces a cardioid pattern, so it's kind of mainly in sort of 3 directions. And again, this is normally a top mount, but it can be a side mount antenna. It's quite a simple installation, and it can be put in radomes that are to shield the total radomes, to shield the antenna. And some of the radomes that we used are actually much larger, and actually you can climb inside it. So you can climb within the radome and service the antenna without the elements, again, depending on what the customer requires. So as well as outdoor antennas, we also have some indoor antenna products. This we call the Hemisphere. This is a very low power because it's only dealing with indoor, only 50 watts. And the nice thing about this is it covers a wide range of frequencies. So not just UHF broadband frequencies, but it would also cover, for example, 5G frequencies, some of the 5G frequencies. And you can actually, because you have that bandwidth, that if you had the right system, you could actually transmit digital television and also 5G signals with the same antenna. So it's ideal for indoor transmission, sort of pico repeater, small gaps. It has an omnidirectional pattern when you mount it on a roof. It's very lightweight and a simple installation, and very kind of small. It's like a half a football sort of size antenna. So in summary, we have a vast range of antennas from 50 watts to 320 kilowatts, many different styles and panels, super turnstiles, slots, a full range of gains and patterns that we can engineer for you. And they can be single channel or multiple channels as required. that's about the end of the presentation. So thank you very much for listening.